Okay, so how's everyone today? Good, I hope. All right. So the first written homeworks will be posted today with messages on where to find them and all of that, and they'll be due a week from today at the beginning. The even ones at the beginning, the odd ones at the end. Any questions about that? All right. So last time we talked about some named sets of numbers. It's expected that you should know these sets of numbers, and you should know the symbol that represents them. So we talked about specifically the naturals, the integers, the rationals, and the reals. So they they're denoted by n, z, q, and r respectively. Okay. So here's a typical example dealing with that. So express the number 20.19016, and with the repeating bar over 016 as a rational. Okay. So the what that means. That means find integers n and d in the integers such that two 0.19016 repeating is n over d. So we need to find two integers. Okay, so here's the idea. So this isn't the work I'd want you to show. Rather, this is the idea that tells us, how we're going to show our work. What's going to be our game plan. So remember that the repeating bar, what that means is that these digits are repeated infinitely often. So the first idea is that that number 20.19016 repeating, that's the same as this number 20.19016 and then 016 repeating. Okay, which is in turn the same as 20.19016 016 repeating. So you can just pull out as many of those groups as you wish. Okay. So that's the idea. That's what that repeating bar means. So here's the idea. The repeating group has 3 digits. 0, 1, and 6. And because we count in base 10, multiplying by 10 shifts the point one position, one digit, right? So multiplying by 10 shifts the point one digit. Multiplying by 10 times 10 is a shift of 2 places. 10 times 10 times 10 times 10 times 10, however many I just said, maybe 5. That's shifting the point 5 places. So what we want to do is we want to shift the point past one such group. Okay, So now, because the group has 3 digits in it, how can we achieve that? So is it multiplied by 10? Would that do it? Nah, that won't do it because that shifts just 1 point. Just shifts 1 digit. What do we need to multiply by? 1,000, right? Need to multiply by 1,000 because that'd be 10 times 10 times 10. Past one such group, and therefore we're going to multiply by 1,000. And this symbol, which I'm going to use very often in the course, that 3 dot symbol, is therefore. So therefore, multiply by 1,000. So specifically, what I want you to observe is that if we do that, we will get 1,000 multiplied by 20.19, and then I'm going to leave the first group 016. I'm going to leave that one out and then write 016 repeating. And now I'm going to perform the multiplication. That's going to shift the point to the right 3 places. So the result will be 20.190 point, because the point's going to move to right. So 1, 2, 3. It's going to move to right there. So then it'll be 16. And then now we have the repeating thingy. So 016, repeating. Okay, so we shifted past one group by multiplying by 1,000. Now, here's the idea. If we can line up now a line vertically with the original number. So specifically what I mean is I'm going to make all the digits line up in columns, and I'm going to make the point line up also. So here's the original number right here. So if the original number's point is lined up with that number's point, then what do I write right there for the original number? 20. And what do I write on the other side? That thing, right? So 19 and then 016 repeating. Okay. Now here's the whole point, and the reason, again, this is not showing the work for the exercise. This is showing you why we're doing the thing that we're doing. So notice that we've arranged matters so that this is aligned. So the repeating groups are now aligned. If we were to do a subtraction now, if we were to do that subtraction, this number minus that number, then all the repeatingness would go away. So can you see it? The whole point is to cause this alignment. Okay, that's the idea. And so now here's the actual work that you'd be expected to produce. Okay, so something like this. You say let x be that number 20.19016 repeating. And I'll note, because I know what's coming, is that I'm going to end up wanting to shift past a group. So I'm going to say that in fact this is the same thing as 20.19, and then I'll write one of the groups 016. So leave it, and then I'll say okay, and here's the other group 016 repeating. Okay. So let x be that. Now, what we're going to do is say, okay, I see that there's 3 digits repeating, and I want to shift a group out. I want to shift out a group, and because there's 3 digits, that means I'm going to multiply by what? 1,000. Okay, so shift out a group. So that'd be 1,000x would be 20190.16, and then now I've got the repeating group. So 016 repeating. So any question about getting to here? Okay, so now we're going to subtract x from both sides. All right. So then it would look like this. So I'll write the left-hand side like this: 1,000 x, and then subtract an x. The right-hand side would be that number. So 20190.16, and then the repeating group, and then subtract. Now instead of writing subtract x, I'm going to write subtract that number there, or no, that number there, right? So it'll be 220.19016. Okay, so I subtracted x from both sides. Now for the left-hand side, it's saying we've got 1,000 x's, and then you take away one of the x's. How many x's do you have? 999 x's. Okay, so then now for this one, instead of performing the subtraction immediately, I'm going to write the subtraction vertically to verify that I got the alignment correct. So what I mean is I'm going to write this. So 20190.16, and then the repeating group 160, and then we're saying that we want to subtract 20.19, and then the repeating group. So do you observe that we achieved the alignment of the repeating group? So now that means that the whole repeating group cancels. So it's nine. Now you can write it as 999x is 20190.16, and then subtract 20.19, because all the repeating stuff is gone. All the repeating stuff is gone, and now this is a subtraction you learned how to do, like in like in 4th grade in Miss Harris's class, right? So this is, you can do this. Okay, so now it is 999x is equal to, so performing that subtraction, that would be 20169.97. That's just typical subtraction there. And what we want to achieve is we want to solve for x. That's what we want to do. So how do we solve for x? Very good. So x is this thing. So 20169.97 divided by 999. So is that the answer to the question? Opposite of yes. So no, right? There's a thing called Betteridge's law of headlines, which is like, when you read a headline on a newspaper or a magazine, or if it's like you've got a link a link to a story, and the link or the headline or whatever is a yes or no question, then the answer is always no. Is this the answer to the question? No. No, it isn't. Is this the end of the United States as we know it? No, it's not. Is this, no. So why is this not the answer to the question?
It can be simplified.
It's not that. That's right. So the request is to find integers n and d such that the number is n divided by d. So the problem is that we've got a fraction there. That's nice. That's good. But it's not one integer divided by another integer. That's bad. Okay. So how do we fix that? Do what?
Multiply by 100.
Okay. So I take it to mean that concerning the numerator, if we could just shift that point past the 9,7, we'd be in a better place. Okay. So I'm going to write down something that's incorrect. So I'm going to do what you said rather than what you intended.
Oh.
20169, but don't worry, we'll be able to fix it. 20169.97, and then you said it'd be great if we could multiply by 100. So all right. Is this okay? So like, you got a bank account. Would it be permissible for you to walk up to the bank and say, "Hey, bank, guess what? I just multiplied my account by 100." Wouldn't that be terrific? No, you can't. You can't just do that. But we do really want that 100 to be there. So how do we make it legitimate? Yeah. Right. So this one down here is what makes that legitimate. So now we've done something legitimate. So the answer is x is now the numerator is 2016997, and the denominator is 999 with 2 more zeros. So now do you observe that we have one integer divided by another? Okay, so this is what was requested. So I'm not really interested in you finding common factors. Those numbers are too big to mess with that. So now, as a check, so to check your work, because it's a good idea to check your work, type that into the calculator. And when you do calculator, and when you do type that into the calculator, what should you get? You should get the number that we started with. If you don't get the number that we started with, then somewhere you made an error and you need to go fish for it. Okay, so let's type that into the thing there. 2016997 divide by 99900. So, moment of truth. I typed it into the thing there. That's what we need to get. Did we get it? Looks good. Okay. So if we got something else, then you'd have to go look for it. Okay. Now to be clear about the expectation. Okay. So a cynical description of what's going on here is that in some sense your entire objective is just to achieve the maximum number of points for every question that I assigned, right? And so that's cynical in my view, because it sort of ignores the whole point of education and everything else, but it's also true. So all right, so to be clear about what's being graded is this process of setting up and solving an equation and doing all this stuff. If this process, setting up and solving an equation, showing multiple steps, if it's not present, then there's nothing to grade and you get a 0. It makes no difference whatsoever if you wrote that number on the page. None. So is it clear? It's the work that's being graded. Good. Any questions before we go to the next thing? All right. So, bad news. Or good news, depending on on your outlook in life, is that now we're going to talk about the order of operations. Order All right, so this is that thing that you learned, you know, back in fourth grade in Miss Harris's class or whatever. Okay, so then you know, back in the day, back at that time, you had a nice acronym that helped you remember the order of operations. What is it? Pemdas. Well, here's the deal: is that Pemdas is not actually correct. And what I mean by that is that it is virtually certain that for each one of you, I would be willing to take like 95% odds that your teacher taught it to you incorrectly. Okay, so then you know, that's kind of harsh, isn't it? Don't you have fond memories of Miss Harris? She was so kind to you. Okay, but all right. Sorry.
My whole life was a lie.
It's going to be one a week after another of this, unfortunately. Okay, but these letters still mean what Miss Harris said. So parentheses. E still means exponent. M still means multiply. D, divide. A, add, and S, subtract. So those still mean what they mean, and it's like very probable that your math teacher at the time said that the way you do it is you just remember the acronym PEMDAS and then you just choose whichever one comes first. Okay, and that's not right. So the rule actually consists of two parts. So the first part is that ties are broken left to right. Which is to say that the leftmost wins. So specifically, here's an example. If we have, say, 3 plus 4 plus 5, then there are two operations in this expression. There's two of them. And then for all the operations that we have, we're going to label the operations with the with the one of the initials PEMDAS. So, you know, what kind of thing is that one? That's an A, right? What kind of thing is that one? An A. So now what I want you to observe is that there's two operations. They're all the same operation, so they're tied. So we have a tie. So the order of operations is telling you the unique operation that is supposed to occur right now. So these A's are tied, so which one happens first? The leftmost one. So the A's are tied, and therefore we choose the leftmost. So this one is the winner. So the next step, you know, performing exactly one step, that would mean, okay, we're supposed to do 3 plus 4. So now that's 7 plus 5. So now we label all the operations. So here's one. What's its label? A. Okay, so among all these operations, which one is supposed to occur first? The only one, right? Okay, so the answer is 12. So far, you know, so interesting, all right. But you might think, I'm not really sure how this has to, what bearing this has. Okay, so here's the place where the bite comes, and it is this. So the operations are ordered in the following way. Ordered. So P, E, so far we're in agreement with Ms. Harris. M, still in agreement with Ms. Harris. But now the D is actually beside the M there, and then we have A and S. So they're on separate levels. So specifically what I want you to see is that M and D are on the same level. So an M and a D can be tied. And then ties are broken left to right. So the operations are ordered top to bottom. Which is to say that the topmost wins. Okay, so now to understand why and how this is different than what you might have previously believed, we can have the following example. Evaluate using the following rules. So evaluate by. So first, label every operation. That is to say, with PEMDAS as appropriate. 2, indicate the unique op indicated by the order of operations. And so indicate the unique op from the order of operations. Three, perform that one op. And then for go to 1. And if, when you're done, when there's no more operations. Okay, so then the expression we're going to evaluate is this one. The expression is 60 divided by 5 multiplied by 4 add 8. So now what I'm going to do is I'm going to do it the way that that you're supposed to do it according to those instructions, but I'm also going to do it the way that you would be led to believe you're supposed to do it in grade school. So I'm going to do it in both ways. I'm going to do it right here. I'm going to do left column, right column. So this is this left column I'll do Pemdas. So this one is incorrect. And then I'll do it the correct way. All right. So we have 60 divide by 5, multiply 4, add 8. So the instructions are explicit. It says label every one. So D, M, A. Is there any question about why that's the case? There's 3 operations: divide, multiply, add. There they are. According to Pemdas, if you have the rule that you consider all the operations and you choose whichever one is furthest to the left in the acronym Pemdas, then that says what are we supposed to do? The multiply. Okay, according to Pemdas anyhow. So this would be 60 divide by 5 multiply 4 is 20, and then add 8. Okay, so now again we label. So we have divide, add. And in PEMDAS, which one do we select? The divide. Okay, 60 divided by 20 is 3. So this would be 3 add 8. So now we label all the operations. Which one are we supposed to select? The only one. And then that's 11. All right. Any question about that? So notice the way the following, ignoring the fact that we're using the wrong order of operations. Notice the way that it works. The expression has 3 operations. You select one and do it. Then you have an expression that has 2 operations. You select one and do it. Then you have an expression that has 1 operation. You select one and do it. Then you have an expression that has 0 operations. And you're done. So if I gave you an expression with like 10 operations, then you'd label them all, select the unique one, do it, and then you'd have something with 9. And then you do all those things again, and you have something with 8. Do all those things, you have something with 7, all the way down to the bottom. Okay? So, 60, doing it in the correct way. 60 divided by 5, multiply 4, add 8. So, label every operation. Same labels, D, M, A. But now things are different. Why are things different? Right. So now, looking at the order of the operations, you can see that multiplies and divides are actually, they tie. So adds are out because it's lower. So add is out. But here we have a tied divide and multiply. Which one do we select? The leftmost one. So that's the winner. So we do it. 60 divided by 5 is 12. I don't know what's going on in my head there. 12, and then now we have that multiply 4 and then add 8. So now we have a multiply and an add. Which one do we select? The multiply. So this would be 48. Add 8. Label all of them. Which one do we select? The add. So 56. All right. So at a minimum, can we agree that PEMDAS and whatever it is that we're talking about right now are not the same thing? They're not the same thing because evidently we're not getting the same answer. Now, you might think something like, well, I don't even know this guy. I know Miss Harris. she wouldn't lie to me. Okay, so in that sort of sense, you have no reason to trust me. All right. So then, fine. Let's let perhaps Texas Instruments. Let's let TI be the arbiter of the truth here. So I typed that into the machine there. 60 divided by 5, multiplied by 4, add 8. Which one does TI think the answer is? Miss Harris. You betrayed me, Miss Harris. Okay, well, so here's the actual truth about that. And the truth is that I don't know who your teacher was, but I have read those textbooks, and they do say PEMDAS. And what they actually do is that every exercise that you're given, where there is multiplies and divides, they always choose exercises where the multiply is to the left, so that PEMDAS and this actual correct version of the order of operations are in agreement. Ha! Wow. So there's this thing called Facebook. You might have heard of it. And on Facebook, all the time, all the time I get to I get sent like the image that says, here's a mathematical expression, evaluate it and respond with what you think the answer is. And then 10 people respond with 9 different answers. You might have seen that. And in the end, the reason for that is just people don't know the order of operations. That's what it is, not following the order of operations. Okay, any question about this? So, you're going to be given an exercise where you have to do this. Is it tedious? Yeah, it's tedious. But it's what's expected. But don't panic because you don't have to do it that way all the time, just on that exercise. Okay? Otherwise, I just want you to just, you know, do it quickly and efficiently. All right? Good? So now these are properties of the reals. So let A, B, and C be in the reals. So all that that's saying is that suppose we've got any numbers at all, and just A, B, and C. So the first property is that we're going to call the commutative property, commutative. So the word commute means to move around. So like student, like, you know, some students live on campus. Students who don't live on campus are called commuters because, you know, they got to drive or whatever to get here. Okay, you got to move around. So then here it is. So we have A plus B. Now if we leave the operation unmoved, so we just leave it still, but we move the A and the B, those are called the operands. If we move the operands around, then it's BA. So B plus A. So those are the same. A plus B is B plus A. It doesn't matter if you take the A and the B and you move them to the other side of the operation. It's the same. Multiplication is the same. So A multiply B is B multiply A. So, you know, the way you might say this is you might say something like plus, you know, add is commutative. Multiply is commutative. Are all operations commutative? No, because for example, subtraction is not commutative. So like 13 minus 14, which is funny because 13, 14 is the course number. 13 minus 14 is -1. But 14 minus 13 is +1. Those aren't the same. Similarly, how about the counterpart to multiplication would be division? How about division? Is division commutative? No. 3 divided by 4 is, you know, 0.75, whereas 4 divided by 3 is 1 point repeating 3. Not the same. So subtraction is not commutative. Division is not commutative. Okay, so you know it's significant to say that, oh, add and multiply are commutative. Generally speaking, many of the interesting things, perhaps most of the interesting things in life, do not commute. An example would be something like something as simple as clothing items, getting dressed. So some clothing items do commute, like left socks and right socks. They commute in the sense that there'd be no way for me to inspect you and say, ha, I've determined that you put on your left sock first. Assuming, you know, that both of them are on, I couldn't detect that. However, pants and underwear do not commute, because I can tell if you put your underwear on last. Right? Good. So not everything commutes. 2. Associative. So now we'll have A plus B plus C is the same as A plus B plus C. Okay. So now that's that. What that's saying is that suppose we have 3 numbers, A, B, and C, and we want to add them all together. So 3 numbers, 2 adds. What the associative property is saying is that well, you can either add the first 2 together, You can do those two first, that's fine. Or you can do the last two first, that's fine. The reason the word associative is chosen because associate means to make a group. So like you could say that here's my associate, my business associate or whatever. Or in the Constitution, the amendment, it says we have the right to of association. We can go meet with other folks, and as long as we're not breaking any laws, no one's going to stop us. Okay. So A multiply B multiply C is A multiply B multiply C, like this. Okay. So add is associative. Multiply is associative. And, I won't bother writing it down, but you should verify that subtraction and other things are not associative. Okay. 3. So now the first two have each line was only about plus or only about multiply, or only about add, only about multiply, only about add, only about multiply. Now we need to say how these things play nicely together. So the name for the way that they play nicely together is called distributive. So the word distribute means to hand out, to give things. So like in a couple weeks I'm gonna have to distribute a quiz to you. I'm gonna have to hand a quiz to all of you. So what we have is A multiply B plus C. So in this way, an A is given to the B and also to the C. So an A is distributed. Here, B, you get an A, and C, you also get an A. So this is A multiply B plus A multiply C. So this is called the distribution of multiply over add. Okay. So now, one thing you might have noticed that's perhaps a little bit different than your previous math instructors is that I'm writing the dot for the multiply. So usually, very often, your math instructor will not write the dot for multiply because just writing things side by side is understood to mean a multiplication, and math teachers are people too, and we're just as lazy as anyone else, and is writing the dot less work than writing the dot? Yeah. Okay. But so I'm as lazy as anyone, yet I'm still writing the dot. So there must be some reason why that's even more lazy than not writing the dot. So in the end, here's the deal: is that I'm not going to require you to write the dot when you mean multiply, but I'm always going to write it. I'm always going to write it, and the reason is because I find that when students get in the habit, if and when students get in the habit of writing the dot, students start making less mistakes. And my life is easier the less mistakes you make, because grading is easier. Grading correct answers is easier than grading incorrect answers. Okay, good. Now the other reason why I write the dot is that now we're going to introduce another operation, and it has its own punctuation that usually isn't written. So specifically, we're going to introduce the exponent operation. So let x be in the reals, and let n be in the naturals. So what I mean by that is that x is just some real number. It's just any number, but n is can't be just any number. It's got to be natural. So what are the naturals? Okay, so nearly. So I'm pretty sure you know what you mean, but So it's all the integers, 0 and up, right? So pi is more than 0, but pi is not an integer. So the naturals are all of the non-negative integers, which is to say the positive integers and also 0. Okay, so now I'm going to write 2 columns. So 2 columns. In the left column, I'm going to write something that you already know, more or less. And in the right column, I'm going to write the new thing, the thing that it's much less likely that you know. So the left column is that multiplication is repeated addition. So now I need to explain what I mean by that. So to explain what I mean by that, I'm going to first omit 2 lines of vertical space. So if you're trying to copy like exactly what I'm writing down, then you need to have that much space there. Okay, so then now 2 multiply x. 2 multiply x. Now, what does that mean? So the definition of that is that means make 2 copies of x. So here's an x. Now I need to put, for similar structural reasons, I need to put just a little bit of horizontal space right there. You make 2 copies of x, and then you add them. That's what it means. 2 multiply x means x plus x. Almost. Do you have any suspicion about 3 multiply x?
X plus X plus X.
Yeah. So now let's make 3 copies of x. And then you add them. Okay. And then, you know, I could do 4, but I won't, you know, I think you can see what would happen. Okay, but here's the deal, is that this digit, this thing, this number, this is what we want to be natural. So is there a natural that comes before 2? Yeah, 1. Okay, so we need to do that one. So 1 multiply x. So in the language that we've been using, that's saying, okay, make 1 copy of x and add them all up. Okay, I did it. So fine, now here's 1. Now, is there a natural that comes before 1?
Yes.
Yes. So 0 multiplied by x. And now we've got a little bit of a problem, because if we're using this language of, you know, make that many copies of x and add them all up, then what am I supposed to write over here? You know, make 0, write 0 x's over here and then add them all up.
Done.
Well, I agree, but now there's nothing on the right-hand side. There's nothing written. That can't be right. Well, what is 0 multiplied by x? You know, using the knowledge that you have.
0.
It's 0, right? Okay, but now there's a question of why it's 0. You can't say it's 0 because Ms. Harris said so. Okay, so really the correct definition is that there's a 0 here. So 0 and then plus and then 0 and then plus and then 0 and then plus, you know, dot dot dot. So like, you know, 97 times x means make 97 copies of x and a 0. You know, make a 0 and then add them all up. That's what it means. All right. Now we have the thing that we want to learn, is that caret, which is the punctuation for the exponent operator. So that's exponent that you usually write as a superscript. Caret is repeated multiply. So now look at the structure, is that multiply is repeated add, exponent is repeated multiply. Okay, that's cute. So again, I'll have two lines that I'll omit for a moment, and then I'll write, okay, what is x caret 2? Which you would, under normal circumstances, write as x superscript 2 and say x squared. Okay, well again, that means make 2 copies of x. So x and x. And then what do we do with them? Multiply them. Okay, and then x caret 3 means make 3 copies of x. And what do we do with them? We multiply them. Okay, so now x caret 1 would mean make 1 copy of x and multiply them all together. And now we come to the problem. Now we come to the thing where it's like, okay, now what? Okay, so then x caret 0 is, well, we're supposed to make no copies of x and then multiply them all together. But if that's it, if that's all of the instructions, then what do I write right there? Yeah? 1. Okay, so there's actually a 1 here. So 1, and then 1, and then 1, and then 1. But it's not, you can't just say because Ms. Harris said so. Okay, there's a reason why there's a 0 there and there's a 1 there. Why?
Because the real numbers are the x raised to 0 still means that there is an x, but it means there is 1. It doesn't matter. I don't know how to explain it, but so x caret 3 is x times x times x
Yeah.
times 1. Because x has to equal something original.
Okay, but it still raises the question of why 1. Did you have something?
So x to the power of 0
Yeah?
is the same as, ooh, I just had the words. It's every time you add 1 to
Mhm.
the
Mhm.
after the caret, you're multiplying that
I just need
original
30
x
seconds.
times 1.
Okay.
Or, like you've taken the x and multiplying it by 1 more x. So
Okay.
x1 is x times x.
Okay, so I agree with that, but now here's the mathy language. So notice that 0 has the property. Multiply is repeated add. And notice that 0 is the only number that adding 0 is the same as doing nothing. Right? Adding 1, it does something. Adding -4 does something. Adding 0 doesn't do anything. 0 is special because it is the additive identity. So we need this number to be the additive identity because multiplication is repeated add. Exponent is repeated multiply. So what do we need this to be? The multiplicative identity. Because what is the only number that multiplying by this number is the same as doing nothing? 1. That's why it's 0. That's why it's 1. That's the reason. All right, have a nice Wednesday.